like that, or actually all the attendees will get an email with the link for that. We also have the hard copy available if you wish. All right, so let's kick it off. Solar Wireless Video Surveillance 101. So the purpose of this presentation is to introduce you to the Hotspot Network's solar power solutions for IB CCTV installations. All right, we want to inform you of the capabilities of our systems, and what we will go through is the fundamentals of solar power, considerations on the site, how to go about installation, battery backup, how much time we'd have, hybrid systems, so that means combination of solar and UPS systems, power types and connections, configuration of the system, maintenance, and troubleshooting. So the most important considerations when engineering these solar powered camera drops is the total power draw of the products being powered, the number of peak solar hours available at that installation site, the voltage requirements of each of those products, for example, 12 volt, 24, 48 volts, and the power connection type, such as PoE or DC terminal block connections. So these are the four main crucial details that your Hotspot Networks pre-sales engineer will use to design the proper solar-powered kit. So brief on power basics. This will help us navigate the world of solar. So there are three main variables that we work with: amps, volts, and watts. A good way to understand them is we compare them to water. An amp is a measure of the electrical current. So you can think of that as your flow rate of water traveling through a garden hose, for example. Amps will quantify the amount of electricity that is moving through the system. So when we combine that reading with time, you will get amp hours, or the number of amps through the system in 1 hour. So you could think of amp hours like gallons per minute in this analogy. So we use amp hours as the amount of stored power in the batteries. And then lastly, you could think of voltage as the water pressure. So if we have at least two of these three variables, we can calculate how much power a particular product, such as an IP camera, consumes, or how long the batteries will be able to power the system for. So as we're going through, keep mind of the wave equation here. Watts equals amps times volts. And we go back and forth between the two to find the other variables. Another power basic: each device, including the batteries, solar panels, and IP cameras, will all have a positive and negative labeled terminal for both power in and power out blocks. This is called polarity. It's imperative that you note the difference between the two and configure the wiring accordingly, as if you install them incorrectly, that can lead to blown fuses or possibly blowing up the device itself in a condition what's called reverse polarity. Our PoE charge controller in these remote power system kits have reverse polarity protection. However, other devices may not have that, such as your IP camera or NVR. So you want to get the connections right the first time so you don't damage these products. Okay, one of the major variables is solar hours or solar peak hours, and that's what your site is exposed to, about 1,000 watt-hours per square meter of solar radiation. So as you'd think, that's generally in the middle of the day, right? That time frame would be between 9 a.m. and 3 p.m. where we're getting most of this solar irradiance. So this graphic shows the average peak sun hours for the United States. And generally, we're given a high and a low and an average peak solar hour reading for each location. We want to use the worst case scenario, though. So we'll use the winter low. And this greatly reduces the risk of under-engineering the system or having a solar power drop lose from lack of solar input. And for comparison, here is the world average peak solar hours for the rest of the world. So, the big concern for customers looking for solar power solutions is how much can I actually power? right? This is a crucial point where you can set yours and your client's expectations on how much we could actually power. So while the sun is an incredible source of energy and power, photovoltaics are only about 25% efficient on average. So this slide shows the amount of watts we can continuously power for a given peak solar hour. You can see towards the southern southwest of the United States, we're getting an average of 5 peak solar hours. With that, we could charge about 50 watts, or we can continuously power 50 watts. And that means through a 24-hour cycle, 7 days a week, 365 days. Compare that to 1 peak solar hour, and we can only power 10 watts. So keep that reference in mind as we move along. So once we find that winter low of the peak solar hours, we need to add up the power draw ratings for every device that we're going to power on the solar job. We want to make sure to use the maximum watt rating for each product, so read those data sheets carefully. Note that some products have a different power draw rating for their PoE power versus auxiliary power. For example, here we have a couple of air-con cameras, one with built-in IR illumination at about 11.5 watts, plus 4.5 watts, and 6 watts for our Station 5+19 wireless transmitter kit. And then add in the micro NVR, for remote recording and backup. And we're looking at about 30 watts. So if we look back at our peak hours and power availability, at 30 watts, we only need 3 hours of peak sun. So the fourth consideration would be power type and connections. So while finding the power draw of each device, you also want to check the voltage requirements and the connection type for those devices. For example, is the camera PoE powered, or does it have that DC power block that we were talking about? Or it potentially could have both, such as the case with the air-con cameras. Is it PoE plus, or is it just regular PoE? 12 volts, 24 volts, right? This information is critical when designing the solar-powered solutions. So make sure to get us the exact part numbers, of course, and the related data sheets so that we can properly engineer these solar jobs. A consideration here are power hogs. So keep in mind that some products have a lot more power draw than others. Typically, you'll want to stay away from PTZ cameras and large IR illuminators. Even though IR illuminators only kick on at night, you'll want to account for the maximum potential power draw when engineering the solar kits. And power draw that increases at night is one of the worst case scenarios, as there's no power being put back into the system as the batteries are being drained. So if the system is not engineered correctly, you'll have a power deficit, and you will have to remove devices or reduce the power load on the system for it to function as intended. So here we have a chart that shows battery capacity and backup time. Let me grab our little pen tool here. So the amount, what we're looking for is we have systems for 50, 100, and 200 amp hour kits. So when viewing the chart, you may wonder why a 200 amp hour kit can have the same as a 100 amp hour kit. If you go back to our brief on power basics, you'll understand why 12 volts at 200 amp hour system is the same amount of battery capacity as 24 volts at a 100 amp hour system. So keep that in mind if the graph seems a little confusing. So our largest solar kit can provide a maximum of 60 watts in 6 peak hour sun. So if you follow that load in watts to the correct graph, you will find the hours of backup you can expect. So for example, here we have load in watts. Let's say we have 60 watts that we need to power. Well, if we follow that up to our first solar kit here, it's showing that we are getting about 5 to 6 hours of battery backup, compared to our highest 200 amp hour system, right? You were looking at about 20 watts of battery backup. Compare that to a lower draw system, maybe at 24 watts, you can get up to 50 hours of battery backup. That's how you can navigate this chart, and this will be available for you after the presentation for reference. Okay. Go back to site considerations. So when choosing where to place the solar kits, the most obvious consideration is shade. You don't want to place solar panels where they will be shaded from the sun, of course. A great rule of thumb is to have a spot that is not shaded from 9 a.m. to 3 p.m. Remember those solar irradiance hours? That's when we're getting the most solar input onto the site, between 9 a.m. and 3 p.m. Watch for potential debris creators such as trees, salt spray if you're near the ocean, and snow. Sand is also a potential factor that can reduce the power output of the solar panels as it can accumulate on the solar panel. The latitude of your location also plays a significant role in the overall power creation potential of your system. So a great tool to find out how many hours of the day a particular location will receive sunlight for is this tool called the Solar Pathfinder. This tool will show you objects nearby if they will shade the solar panel. Again, that rule of thumb, make sure you're not getting shade between 9 a.m. and 3 p.m. For your maximum solar input. This is more crucial in the winter months as the solar output is reduced as the sun is lower towards the horizon during the winter. The solar maps are specific for this product, and they come in a series range of latitudes. So if you do purchase this product, keep that in mind. Make sure you're getting it for the right latitude. This one would be for 37 to 40 degrees north latitude. So when orienting the solar panels, align them to true south. The angle of the solar panel to the sun is of great importance as well, as you'll want to maximize the power generating potential of the panels by angling them as close to perpendicular to the sun's rays as possible. We know that the sun's path moves lower in the sky as we move from summer solstice to winter solstice. So unless your panels are on an automated sun tracker, you won't be in optimal alignment all year long. So the goal then is to set the solar panel tilt for the optimum winter solar angle. And we will give you that winter solar angle. It's just a calculation of the latitude. So for pole and hole sizing, most likely you'll want to consult a your local building codes and a local engineer. Here's some general guidelines given the module square foot. This would be the size of the solar panels. Our solar panels aren't getting more than 20 square feet, so the rest of this information is not applicable. This will give you a good frame of reference as far as the Schedule 40 size pipe that you'd need, the depth in ground that you will need in inches, and the height above the ground in inches for the pole or for the concrete footing here, and of course the hole width as well. So use this as a general guideline so you can factor in costing, but it's always recommended to consult a local engineer. Wind loading is also another factor you have to think about. Again, highly recommended to consult a local engineer, as we can engineer the solar portion, quote the products, and make sure you have the correct solar peak hours to power the system as far as installation on a particular pole. Consult the local engineer for those calculations. So here's what the overall system looks like when mounted. More than likely, you will have a hotspot wireless gear installed on this solar job. Generally, you want the wireless panel antenna to be installed highest on the pole. If this will cause significant shading in that 9 a.m. to 3 p.m. time slot, consider installing that panel below, the wireless panel below the solar panel, making sure that the wireless antenna is not being blocked by the solar panel. So for internal mounting inside the steel enclosure, you have multiple options. You can mount to the back mounting plate or to the DIN rail located on the inside door of the enclosure. There's many pre-hole drills in there, so you can add DIN rails as necessary. If you have an existing light standard that you're installing to, you may be able to draw power from that pole. You'll want to check for the presence of a photocell located directly at the top of that light source. If no photocell is present, most likely the pole will not have continuous power to the light and might be relayed back to a central power controller. So this means you will have power during night when the lights come on, but not in the daytime when the lights are off. So if you don't have continuous power on that pole, we can engineer a UPS system, or an uninterruptible power supply system, without solar panels, which grabs power from the pole during night and then runs off the batteries during the day when there's no power on the pole. Or we can create a hybrid system between the two solar and UPS systems. So maybe you already have power at the pole, but you want to provide an incredibly robust system capable of powering the cameras and the wireless equipment in the event of a catastrophic power loss, for example. So we can engineer both the UPS and the solar system in one system for greater reliability. Some cool accessories that you'd want to consider is adding the web-based controller, which will allow you to remotely monitor your system, including temperature and voltages. You can also relay products, flip them on and off, and cycle power to them remotely, which is neat with that web-based remote monitoring control. In very hot climates, it's a good idea to add the power ventilation adapter, and it usually kicks on about 122 degrees Fahrenheit, and will generally cool the system in about 5 minutes, which is going to give your batteries longer life and have more battery capacity. That web-based monitoring tool, this is what the interface would look like. You could access it via the web browser, either from a local network or over the internet. You can monitor up to 4 voltages, 4 currents, 2 temperatures, and control power to devices for up to 4 relays. So for configuration and installation, you must make sure to connect the batteries to the solar charge controller first. Connect them with the appropriate polarity, of course. Even though we do have reverse polarity protection, you want to get it right and not rely on that reverse polarity protection. So from the batteries to the PoE charge controller at the terminal labeled BAT is where you install the batteries. Then you'll connect the solar panels to the positive and negative terminal block labeled SOL for solar. Third, connect the products that will consume power. Of course, be mindful of polarity here if it's a DC in block. Then you could finally add your data connections with Ethernet cabling. So this shows the solar kit without a PoE charge controller. So this is one way we can connect. If we have multiple cameras, we have a PoE switch there. You could do up to 4 cameras. Or if it's just a single camera, we would do a PoE injector. Or in the case of the Aircon cameras, it would be DC power block in. And here's a generic wiring diagram for the UPS kits. So maintenance considerations. The only real maintenance consideration is keeping it clean. If you're in an area where corrosion is a potential threat, check cables and connections when necessary to prevent failure of parts. Other than that, batteries and the rest of the components are fairly maintenance-free. These are glass matte gel batteries, so there's no needing to add water to them. When installing wireless gear along with the solar kit, make sure to follow the standard weatherizing protocols as detailed in the wrap manuals. And life expectancy on these guys, For the battery, you're looking at about 5-year life. We do have a 2-year warranty on it. And with the solar panels, you're guaranteed at least 25 years of solar output, or the rated output for those, as long as you keep them clean, of course. And those are warranted up to 5 years. And for troubleshooting, you want to invest in a voltmeter. This will tell you how much power you're getting at key contact points, such as the voltage coming from the solar panels into the charge controller, the voltage coming out of the charge controller to the load, and the voltage of the batteries. So if your system is not recharging enough to allow for uninterrupted power, note the circumstances, such as, has there been storms recently? Is it winter? Do we have lack of sun? Have you added a new power-consuming device to the system? So collect this information and consult your Hotspot Networks technical support for help there. In a 12-volt system, the system will shut down if the batteries are below 11 volts. Now, the good thing here is it won't start back up until it's fully recharged. And on a 24-volt system, it will shut down at 22 volts, and it won't turn back on until it's fully recharged. So again, fully charged batteries measure about 13.5 volts for the 12-volt config, and for the 24-volt config, it would be 25.5 volts. Batteries must be between 11 volts and 15 volts for the load light to be on the 12-volt config, and that means it's charged, ready to go, can power up your devices. For the 24-volt config, you want that power to be, the battery readings to be between 22 and 29 volts for the system to be kicking on. And to reiterate, if the batteries do run out, the system will charge the batteries to full before turning the power back on automatically, and that helps to prevent a scenario where you're only getting enough energy to turn all the products on, and then they turn off, and they can potentially surge and power those or damage the devices. So it's a good thing to have a system that once drained out, shuts down and only turns back on when the batteries are fully charged. Again, that voltmeter is going to be your best friend to check battery capacity and solar panel output. So we'll get into some projects here. Here's a very simple one, a remote micro NVR with a PTZ camera and housed in a .works enclosure. We had our remote power solar kit powering up that device. There was a 3G, 4G cellular modem attached to the micro NVR, so this was a completely automated, remotely powered or solar powered system that could be controlled over the internet by the Caltrans staff. We also have oil and gas fields outside of the United States where we are, simple perimeter security with wireless point-to-point links. And most recently, Yuba-Sutter Transit had a fairly large install. There was 3 locations. Each location had a head end, a remote head end inside this enclosure with our micro NVR product, one of our wrap base stations with an Omni antenna and its Aerocon cameras. This was our UPS system, so we're drawing power from the pole at night, and then in the daytime, when the lights turn off, there's no power on the pole, we run off the battery system from that UPS. There was sufficient power that we were, sufficient amount of hours that we were getting to power the UPS, so there was no need to do a hybrid UPS solar system on here. For the remote units with the cameras that were pointing back to this remote head end, those were solar powered. So there's about 3 locations with 3 head ends, and then each had 3 remote solar powered jobs. And this solar powered job consisted of our 120 watt panel system, or 30 watt system with 120 panels on them, and our Station 5 plus 19 units, all shooting wirelessly to this head end to the micro NVR. The micro NVR is broadcasting a Wi-Fi access point so that the customer can cruise up within 300 feet to access that video. If they want to view it remotely over the internet, all they need to do is throw a 3G, 4G cellular modem into the micro NVR, and then they could have access without needing to be physically on site. So at this point, we'll open up to some Q&A. Let's see here. Let me see if I have some questions here yet. Not so far, but go ahead and fill those in as you start having questions. Again, of course, we do engineer these systems out, so this presentation is basically drumming up your interest in this, showing you what we're capable of doing, what's realistic, what's not. Solar power isn't the magic bullet, but we can certainly power up to 50 watts per drop. Now, in the near future, we'll be having higher capacity solar panels, hopefully to be released soon. So I believe we'll be able to do up to 100 watts per drop. So in that case, your PTZ cameras will be viable at that point. So use that questionnaire box in the right-hand side so we can answer some questions. Hopefully, if you don't have questions, then we can, let's see, we have some hands raised here. So David, you have your hand raised. I'm going to unmute you if you have a question. Hey, David. Oh, I think you took off. So while we're waiting for some questions, we'll launch some polls here. And as soon as you answer them, we can get those out of the way. These polls help us, fine-tune these, see if they're too long, not long enough, need more info. It allows us to judge how well we're doing here. And we're getting some answers in, so let's see. The majority says, I'm considering offering this technology. Or it's just general education. About half of you are saying general education. A few of you say you have an immediate project. That's great. We'll get your information, and feel free to email me at mike@hotspot.net or give us a call, 805-541-9477. I'm at extension 6003. All right, I'm going to close that poll. Let's see. Okay, we got some questions here now. All right, is there a certification class that our techs installers would need to take, and if so, how often do you provide those classes? Yes, we do absolutely for the wireless and for the solar. Generally, it's best to do it in a PowerPoint or a webinar style, as it allows you to stay at your location and us at ours. It's fairly straightforward for the installation. Most of the stuff is bolt-on and plug-in. There's very little technical configuration. On the wireless side, you're mostly changing a access point to be a access point mode, and then the other device is already pre-configured to automatically talk to that access point. So on the wireless side, it's fairly straightforward. On the solar side, it's essentially bolt on to a pole and plug in the wires in the right connections, as they're already pre-configured or pre-engineered to support your solar or your powered drop, and of course the correct connections, whether it's PoE or DCN, are already engineered for you. But yes, we do have training available. Short answer. Specs on the switches used. How well do they survive temperature variances? These would be considered hardened switches. So you're looking at, the -20 to +70 degrees Celsius for most of this equipment, including the switches. And we can send you spec sheets on those, Scott. Thank you for that. David, no problem. That's all right. If you didn't have a mic, just, yep, it looks like you got a question here. So David's question, do you have a calculator on the website for basic power calcs? I don't believe it's on the website. We encourage you to come to our pre-sales engineers so that, we catch all the little nuances of the project. That's the most important aspect to these solar-powered installations. Not just the overall power draw, but how those devices are powered. Do you have the proper connections? Do we need a switch versus an injector? So how everything connects up on the data side and power side is, of course, of utmost importance when you're sitting up there on a $2,000 rented lift. All right, thank you, David. In Iowa, we see 100 degrees Fahrenheit in the summer and -15 in the winter. Yeah, so -20 Fahrenheit to +70, you're looking at 145, 150 Fahrenheit for 70 degrees Celsius. So in the enclosure, of course, it can get hotter. At that point, I would recommend using the power ventilated system. That only adds about maybe 3 watts to the overall power draw. So it's definitely an effective, viable solution for high power or high temperature locations. -15 in the winter, the devices inside are generating some heat. Depending if you have a micro MVR in there, that will definitely keep the system to optimal temperature in the winter. At -15, in very low temperature areas, it does reduce the battery capacity, but it would take quite a bit more than -15 to have a major effect on the battery reduction. Do you have mobile solutions for well sites? Yes. Give me more details on that. We can talk later. If you're talking about more of a nomadic solution, maybe a Pelican case with batteries and a camera and an MVR, I believe that's probably what you're referring to. Yes, we have all the parts and pieces for that. A turnkey solution in a Pelican case, no, but we can certainly help you engineer that system. If you haven't seen our micro MVR product, the micro MVR 1000, it's an NVR, very small form factor, about 4 inches square, only consuming about 10 watts of power, and that will allow you to connect up to 4 cameras, IP, HD, 10 frames per second cameras, and has a lot of I/O for your data connectivity, whether that's gigabit Ethernet ports or the 802.11 wireless. You could also do cellular within that. All right, let's see here. Thanks for that question. Please send me your info. I will do that. Patrick, thank you. Is it UL listed, Underwriters Laboratories? Yes, that should be. I'll double check on that, but yes, it should all be underwritten. Can you send the presentation? Yes, we will be able to send you the presentation, Paul. This is recorded, so it's being recorded format and the hard copy of the PowerPoint. Thanks, Brian. Thanks, Harris. Do you guys make a dual radio with Wi-Fi and 3 or 4G? Thanks. Thank you, Brian. We do have, of course, our DX units or dual radio units that are Wi-Fi frequencies, of course, 5.8, 2.4. We do anything from 200 megahertz to 6 gigahertz within our wrap products. and that could be anywhere from 1 radio module up to 4 radio modules in a single unit. Now with 3G, 4G embedded, we do have a product that has that. However, it's not just a off-the-shelf device. There's particular modems that we need to use, and I can send you a list of those. With the Hotmobile device, you have an external USB port. So if we're talking mobile applications, you could throw in an approved 3G, 4G modem in there, and it can fail over to cellular if you roam outside of Wi-Fi connectivity. The Hot Mesh device has 2.4, 5.8, 900 megahertz, 4.9 gigahertz radio cards in them, and then has the opportunity to add cellular modems via USB. And then we can do all sorts of really cool routing between them, load balancing, failover, in a always connected type of architecture. So awesome. Thank you guys for all those questions. That seems to be all of them. I'll give you another questionnaire here as you guys drum up more questions. So the question is this presentation useful to you? Half of you already voted and said yes, thank you. We'll go ahead and close that. Sounds like the majority of people are saying yes. Last poll here, and then I'll leave you to the rest of the questions. What's the question here? I guess I should know these questions. How do you describe your involvement with Hotspot? Are you a system integrator, Hotspot channel partner, solutions partner? Are you a rep? And most of you are saying you guys are system integrators. We have a couple solution partners as well. Great, thank you for answering those. And that's the last poll. We'll give it a solid minute and a half for any more questions, and then we'll close it. And we definitely thank you guys for attending these. This was just one in a series. This is the second time that we've done the Solar Wireless Video Surveillance 101 webinar. Luckily, we recorded it this time, so it will be available online. We have other presentations, the titles of which escape me, but generally they were how to design static and mobile wireless solutions. There was Safe Cities, which covered how do we get video from all these disparate systems into the decision makers, aka police and fire, EMS. How do we get all these systems that are within a city? It might be a Vigilon or Exact Vision, on the side, Nuo. How do we get that video to the people who need it? So we have solutions for that as well, and that will be available. That's already available online or on YouTube. So if you go to our Hotspot Networks YouTube channel, you can see some really cool webinars that we've already done and some solutions that we provide. So I'll start wrapping it up here. There's still quite a lot of people on. Give you one last chance to ask a question, then we'll wrap it up. Let's see. Did I lose my questions here? We got some more questions. Define channel partner and solution provider. We can, so solution provider, right, would be a, well, actually, that's a good question. I'll define that in an email, Roy, and send it your way. Our channel partners, of course, you have the opportunity to purchase direct or go through distribution. We have our rep channel, of course, throughout the United States. And solutions provider, I'll send you a detailed information on that, Roy. Who do I need to call for more info? You can call me at Hotspot Networks, 805-541-9477, extension 6003. We will send out contact information to everybody who attended. You did say that you were sending us all the links to this PowerPoint, right? Yes, we will do that, Shannon. Thank you, Patrick. All right. Last chance. Question. Thank you. Thanks, Paul. And we'll call it. Thank you guys for attending, and we'll have more of these that will cover different topics. Be sure to check out the website, hotspot.net website, for up-to-date information on new projects that have been installed, new products that are coming out, and just general information on our company and solutions. Thanks, guys, for attending. Take care.